Alright, biggest thing here on number 3 is that it's going to be a slant asymptote. So first things first, we'll get to the graph side of it in a minute and whether it is has symmetry rather. First off, so we need to hit a couple of things as far as the x-intercepts, the y-intercepts, the asymptotes, things like that. So first off, whenever we hit the the x-intercept, so whenever we're going to find the x-intercept, we've got to set the top equal to 0. So we're going to set x squared plus x minus 2 equal to 0, and those are going to give me my two intercepts. So this one's factorable, so we're going to have x, we're going to have a plus 2, and then we're going to have an x minus 1. They're both equal to 0. So my two x-intercepts here are a negative 2 and a positive 1. So what I would suggest whenever you're doing this during your test is to make sure, go ahead and plot those points. It'll make things a little bit easier. So that way we already have a spot here at negative 2. We have a spot here at positive 1. Okay. Now from there, it is going to have a vertical asymptote because, or let's go ahead and get to our y-intercept if we have one. So as far as our y-intercept is concerned, that's when we set everything equal, or all the x's equal to 0. So whenever we do the y-intercept, we're going to have 0 squared plus 0 minus 2 all over 2 times 0 minus 1. So whenever we do that, we get negative 2 over negative 1. So my y-intercept is going to be at a positive 2. So again, go ahead and put that point on there. Okay, that's just less that you have to worry about later. So from there, let's find our vertical asymptotes. So vertical asymptote, all we need to do is set the bottom equal to 0 and see what x cannot be. So I'm going to have 2x minus 1 equals 0. So 2x is equal to 1. X is going to be equal to 1/2. So again, just like we've talked about, go ahead and run your dash line right down about where 1/2 is and go from there. So whenever we do, there's our vertical asymptote. Now, it does not have a horizontal asymptote because of our powers. Since the top power is bigger than the bottom power, okay, then it is going to be a slant asymptote. So as far as a horizontal asymptote, okay, all you'll put there is in A, you'll put none, okay, whatever you want. So since it's a slant, you're going to put a slant asymptote. All we're going to do, you're going to take that 1/2 that you have right here, okay, and you're going to just do synthetic division. So if I have 1, positive 1, and negative 2, I'm going to put the 1/2 here. We're going to drop it. We're going to go 1. That's going to be 1/2. So 3/2. Multiply that by 1/2. We're not really worried about all that. Okay. Really, this part right here doesn't matter. So I have x plus 3/2. Okay, you can also call this 2x plus 3. So however you want to look at it. So if we go from there, I'm going to have a dashed line. So it's going to go basically through 1.5. I'm going to go up 1 over 1. And it's going to look something like that there. So there's my slant. The numbers and the points kind of tell you where it's going to look and what it's going to do. So again, we need to run basically along. The graph is not the big part here. Okay, it's just going to run right along here, and it's just going to turn. It's going to look something like that, and then again like this here. Okay, the points that we already put in there tell us what it's going to do and how it's going to look. So there's our graph. We still need our domain. Our domain's just going to run negative infinity. Okay, in this case, it's going to run negative infinity to that positive 1/2, and then from 1/2 to positive infinity. Okay, all we did was just look because it's basically picking up from that spot, from that vertical asymptote. My range, it's going off negative infinity. Okay, if you look, even if you just look at the one side, it's going from negative infinity. It's just going to keep climbing. Okay, it's going to keep going to positive infinity. So in this case, our range is just going to go from negative infinity to positive infinity.